Welcome back, friends. We have been solving CSIR problems. This is a problem. This is one of the problem asked in CSIR, June 2011. We are given that I be a set consisting of the singleton set 1 and 2, union of these two, as a subset of R. And we are also given that for x in R, let phi of x is equal to distance between x and I. So it's a distance between the set I and the point x, where x is a real number, and it is defined to be infimum of modulus of x minus y such that y belongs to I. Then we are given four options. Phi is discontinuous somewhere on R. The second option is phi is continuous on R but not differentiable only at x is equal to 1. And third option is phi is continuous on R but not differentiable at x is equal to 1, 2, 1 and 2. Fourth option is phi is continuous on R but not differentiable only at x is equal to 1, 3 by 2, 2. Now let us try to find the correct option. So what are we given? We are given that I is equal to union of two singleton sets, and obviously they are subsets of R. And we are also given that phi of x is defined to be distance between the point x and I. So here phi of a is equal to distance between a and I, where I is equal to set containing 2 points. So that is equal to infimum of modulus of a minus y. Y belongs to I. Y belongs to I. Okay. Now what are the two possibilities? Now simply since I being a set containing only 2 points, let us replace this y by a minus 1, a minus 2. So you can give values for y. It can be either 1. So when it is 1, we write mod a minus 1. When it is 2, we write mod a minus 2. Okay. Now how many points are there? How many values are there? This is a real number and this is a real number. So this is only a finite set containing only 2 points for a particular value of a. So infimum becomes minimum. So when the set is finite, infimum coincides with minimum. When the set is finite, infimum coincides with the minimum. So now we have to find the minimum of these two numbers. So what do we do there? To find the minimum, what do we do is, you take your a is a real number. So when a lies to the left of 1, suppose you can take your a to be the left of 1. So what will happen? You can take anywhere on the x-axis, which is a real line. You can take any point, so you can call it as a. Or you can take a to be here. So anywhere on the left of 1. So the distance between a and 1. Now consider the distance between a and 1 and consider the distance between a and 2. So which is closer to a? Obviously 1 is closer to a when compared with 2, which is far away from a. So in that case, whenever a lies to the left of 1, this minimum becomes, so phi of a, let us write down, phi of a is equal to modulus of a minus 1, provided a lies to the left of 1. So the argument is the same when a lies to the right of 2. So argument is the same when a lies to the right of 2. So when a is greater than or equal to 2. So when a is here, distance between a and 2 is lesser than the distance between a and 1. So 2 will be, whenever a is here, this distance is the smallest distance compared to this distance. Anywhere on the right of 2, if you take a to be. Now the question is, what happens between 1 and 2? So the midpoint of 1 and 2 is 1.5, namely 3 by 2. So when a lies to the left of 3 by 2, distance between a and 1 is lesser. Distance between a and 1 is lesser. So this is a minus 1, modulus of a minus 1 whenever a is less than or equal to 3 by 2. Likewise, when a lies between 3 by 2 and 2, so distance it is going to be a minus 2 whenever a is greater than 3 by 2. So when it is right of 3 by 2, this is the value. Now let us make use of the absolute value function, definition of the absolute value function, and see that let us try to draw the graph for all these things, for all the four possibilities. So when a is less than or equal to 1, what will happen? When a is less than or equal to 1, it is going to be here or here. So a is definitely less than 1, therefore the quantity inside this is less than 1. So when you apply the definition of absolute function or mod function definition, what you will get is 1 minus a. This is a less than 1 or equal to 1. Less than or equal to 1. Okay. So this is the definition. When a is greater than 2, so it is going to be positive. So the graph is going to be a minus 2 itself. So whenever a is greater than or equal to 2. Okay. So, and what happens when a is less than 3 by 2? It is a minus 1. It is a minus 1 because a is less than or equal to 3 by 2. So it can be greater than 1 and less than 3 by 2. So the graph in this case is going to be, it is a minus 1 itself. A is greater than or equal to 3 by 2. So we are settling down the mod function. When a is less than or equal to 3 by 2. When a is greater than or equal to 3 by 2 and less than 2, greater than or equal to 3 by 2 and less than or equal to 2. So this is a negative. This is going to be negative, and the value is 2 minus a. 2 minus a. When a lies between 3 by 2, so 3 by 2 or let us write like this. This is a minus 2, right? This is 2 minus a, comma 3 by 2 less than or equal to a, less than or equal to 2. When a lies this. Now let us try to graph this function. So if you draw the graph, you will be able to get the answer. So what is 1 minus a? When I substitute here, it is 0. When I substitute a is equal to 0, it is going to be, when I substitute a is equal to 0, it is going to be 1. So this is our phi of x. So when I substitute a is equal to 0, I am going to get 1. So graph is going to be something like this. The line is going to be something like this. Okay, or phi of a rather. When you substitute, you take this case to the right. Let us guess when a is greater than 2. When a is greater than 2. When a is equal to 2, it is 0. When it is 3, it is going to be 1. So the graph is going to be something like this. What happens at this point? When a is equal to 3 by 2, when you substitute 3 by 2, at 3 by 2 it is going to be half. So it is going to be half. So graph is something like this for this one, for the third case. And for this case, the graph is going to be something like this. You can check it out. When a is equal to 3 by 2, 2 minus 3 by 2 is half. That coincides with 2. And when a is equal to 2 minus 2 is 0. So this is the graph under consideration. Clearly we see that the function is continuous at every point. See that phi continuous, right? Because graph exists for every point in the domain. So function is continuous. So the option 1 is false. The f is discontinuous somewhere on R is false. So function is continuous. And we can see that there are sharp vertices at the point, V-shaped vertices at the point 1, 3 by 2 and 2. They are all points where the slope changes sharply. So whenever we have a vertex of this type, V-shaped vertices, they are all not differentiable, because here the slope increases immediately, in the neighborhood of that slope decreases. So 1, 3 by 2 and 2 are the points where the function fails to be differentiable, continuous, and x is equal to 1, 3 by 2 and 2 are the V-shaped vertices. V-shaped vertices where the function is not differentiable. This is because, so not differentiable. Option, that means option 3 is false, because we are 3 by 2 is left out. This is false, and this is also false. Option 4 is correct. Option 4 is correct. Let us explain this. What is V-shaped vertex? Why it is not differentiable? We will explain in a while from now. See. Now we will justify how this function doesn't have limit at the point x is equal to 1 and 3 by 2 and 2. Why it is not differentiable at these points? We will justify using the definition of derivative. We know that the derivative of a function at a point is, this limit is what is called derivative. Now we will show that this limit does not exist at x is equal to, a is equal to what? A is equal to 3 by 2 and a is equal to 2. Now you consider the limit on the right hand side. So limit phi of a plus h minus phi of a by h, this is the definition. Now we consider the left hand side limit. When h is tends to 1 minus, so to the left of 1, now we take this function to be, the function to be 1 minus a, because a is left of 1, the function is 1 minus a. And there is a correction, we have made a change here. When a lies between 1 and 3 by 2, this is the function. So you please make a note of this domain of a. We have made a correction here. Okay, right. So phi of a plus h, by the definition of phi of a plus h, now 1 minus a plus h. So because h tends to 1 minus, so left of 1 phi is defined like this, 1 minus a. So phi of a plus h is 1 minus a plus h. 1 minus a plus h minus phi of a is 1 minus a by h tends to 1 minus. Now you apply. Now this a minus into minus plus a and this a will get cancelled. This is minus h, this is minus 1 and this plus 1. They will cancel each other. So we will be left with minus h by h, which is minus 1. So the left hand side limit is minus 1. Now when h tends to 1 plus, so when h tends to 1 plus, you are approaching 1 from the right. So a lies between 1 and 3 by 2. 1 and 3 by 2. In that case, we have to take the definition of phi of a to be a minus 1. So what will happen? A plus, so phi of a plus h is a plus h minus 1 minus phi of a is a minus 1. We are taking the definition, third one. This one we take phi of a to be a minus 1. So a plus h minus 1, because phi of a plus h is a plus h minus 1 minus phi of a is a minus 1. Now minus into minus plus, this 1 and 1 will cancel out each other, and this will cancel out each other. So what we will be left with is, we will be left with h over h, which is 1. When you, the left hand side limit is minus 1, whereas the right hand side limit is +1, so of this function. Left hand side limit is -1 and the right hand side is +1. Both the limit exist but they are not equal. But for the derivative to be to exist, both left and right hand side limit must be unique. They must be equal in fact. So in this case it is not, they are not equal. The same thing is true at other points also. That if this function doesn't have limit at the point x is equal to 1, 3/2 and 2, so it is not differentiable. Okay, that's the reason for it.